Okay, so today we're going to go over muscle modeling and this sort of little simulation exercise using elastics. And let me just get my cursor up here. Whoop. And so the first thing I'm going to sort of explain is that using muscle modeling or simulation software, a lot of the times what we'll do in terms of reducing something down to its mechanical system is have a skeleton, so still utilizing the bony prominences and the proper force application, proper joint centers, but then reducing a muscle down to these very sort of minimalistic structures, which are just the elastic tensile elements and the active contraction capacity of the muscle. So in terms of calculating the moments or where the actual force is applied by the muscle, it's pretty reductive, but it gives you a good sense of exactly where the muscle is applying the force and how much force needs to be applied through the muscle in its active component, and it really helps with the calculations and looking at the joint torques. So what we're going to do is I'm going to show a little video of a demonstration that we typically do in class. Obviously can't do that right now, but what this is going to be is a quick video of that, so you can kind of see what we're doing and how it can be useful and sort of like an interesting little exercise before you start utilizing complex simulations and things like OpenSim, where this figure is taken from. So what we're going to do is going to be looking at a couple different muscles, specifically the joint. Like we're going to be looking at is the elbow and ankle here. We're going to be looking at biceps brachii, where you specifically pick the long head. It doesn't say that, but that's what we did for this experiment. Brachioradialis and then gastrocnemius, we specifically picked the lateral head. We just sort of picked those. We're going to position the joints at 3 different joint angles, 45, 90, and 135 for the elbow, and then 75 and 135 for the ankle, just 2 different joint angles. For each one, we're going to measure the distance from the origin, so the origin of the muscle where it begins proximally to the joint center, then the distance from the joint center to the insertion, so where it attaches to the bone distally, and then what we're going to do is measure the actual length that the muscle covers. So because we're using these little elastics, like I said, it's sort of an elastic mechanical system, we're going to be measuring the change in length of the muscle, and then one of the things that we're also going to measure is the angle that the muscle makes with the bone at its insertion. So we're going to go through and fill out these. In this chart, a good way to think about this is that all the white columns are going to be measured and all the black are going to be calculated. So I'll leave the black ones for you guys to calculate later, but Ian and I go through and we collect all the different measurements you'll need in order to do this little exercise at home in these white columns here. So you can see what we've done here is create our little, if I get rid of my pointer here, created our little elastic system here for the long head of the biceps. We have it attaching to the supraglenoid tubercle above the shoulder, running through the bicipital groove. We attached a little piece of tape so it doesn't slip out in order to get the correct line of action. If you don't have the correct line of action, this isn't actually that useful. Obviously you have aponeurosis and different things interacting, connective tissue holding the muscle down, so you don't have this complete bowstringing effect of the muscle. But in terms of going through a complex joint like the shoulder, I did want it to run through the bicipital groove to make sure that it gets the proper joint angle or interaction with the insertion point. So what I'm going to do here is I'll just play this video. You can see that we just made this little black elastic and taped it to the bone at the origin and insertion, and that is kind of acting like our very minimalistic representation of the long head of the biceps, acting in accordance with elbow flexion. So again, long head of the biceps is a supraglenoid tubercle of the scapula, and insertion is a posterior border of the bicipital or radial tuberosity on the radius here, and then long head inserts there on the supraglenoid tubercle. So that's just so you know where we tape those if you ever want to do these on the skeletons, or you've got a model somewhere. You can see it a little bit better here, but I'll play this and just sort of show you how we measured those. So first I take my goniometer, position it to our first joint angle, which I believe is 45 degrees. I don't have it exactly in front of me, but I position it to 45 degrees, try and get that joint to the proper positioning there. It's kind of hard to see with the camera without completely blocking it out, but I get close enough. And then what Ian's going to do is he's going to measure from the origin to the joint center, take that measurement, and I'll show you all these as he writes them down. I'll put them into that chart after this. But he takes from the origin to the joint center as I clumsily pass him the clipboard. And so the next thing that he's going to measure is from the joint center to the insertion. Again, it's a little hard to do with the tape here, but you have to sort of have a piece of tape marked and have the person do it consistently, and then you'll have a better reflection of what all these measurements are. He's going to record that. Again, we're keeping the joint at 45 degrees, just verifying that. Next, he's going to measure the entire length of the muscle. In this flex position at 45 degrees, you can sort of help the person hold it. Again, it's kind of like a little cumbersome exercise here. He'll take that measurement from the origin to the radial tuberosity in this flex position. And then finally, what we're going to do is measure the angle that that muscle makes at the insertion point with the bone. So I'm trying to get Ian to stabilize it here, and don't mind me as I block out the camera for a second, but I'm trying to get the goniometer to line up one arm with the muscle and then one arm with the radius. And then I'll record that. I'll just let you guys sort of watch these here as we go through, but without necessarily recording it yourself, you just need to know the process. Again, we're going to position the joint at 90 degrees here. You can already see that the muscle is looking a little bit different in terms of the distance that the moment was from the humerus, but Ian is going to measure again from the origin to the joint center. I'm sort of holding that so it makes sure it goes through the bicipital groove. Then from the joint center to the insertion. Then we're going to take the total length of the muscle. Again, for that first measurement, the origin to the joint center, it didn't have to go through the bicipital groove. I just know he did before, so I wanted to keep the measurement consistent. He'll take that measurement, and then I'll get the goniometer, and once I can get Ian to support the arm here, then we'll measure the angle that makes with the bone if we don't bump it and completely mess up the data. So verify that that joint is at 90 after I moved it. And as our camera does a weird little focus thing. Then when Ian supports that, we've got the joint back in place. Measure that the angle the muscle is making with the radius at insertion. Finally, we're going to do the same thing just for the last joint angle, which is 135 degrees. And by this point, you probably know the drill. You're going to position the joint at 135 degrees. Ian's going to measure from the origin to the joint center, from the joint center to the insertion, the length of the muscle, and then finally we'll measure the angle the muscle makes, with the radius. Here from the joint center to the insertion. length of the muscle, and then finally the angle that the muscle makes with the bone at insertion. So you kind of get the idea of the protocol there. What we can do now, let's go through and look at the data we recorded. So everything's in meters. So the distance from the joint, or from the origin to the joint, is 37 centimeters. The distance from the joint to the insertion is 4.5 centimeters. The muscle length in meters was calculated at 33, 36, and 38 centimeters. And then finally we measured the muscle angle that it makes with the bone at insertion at 145 for our 45 degrees, 85, and 40 respectively. And again, these are all in degrees, not radians. So I'm going to increase the size of the screen share here just because I don't need to talk you through everything. And we'll move on to the next slide here. Just ensuring that you know that brachioradialis, the origin, is the upper 2/3 of the lateral supracondylar ridge. So above the condyles, you have this ridge on your humerus. That's where the brachioradialis originates, and then it inserts at the base of the radial styloid, just proximal. This actually looks like it's a little distal. It inserts just proximally there. And yeah, so again, the action is to flex the arm. So we're comparing two elbow flexors here. So the elbow is still the joint of interest, and you can see that we've taped our brachioradialis a little bit differently, but compared to the biceps now, we have our origin and insertion. Position the joint at 45, just like we did before, and then take all those same measurements. So again, those measurements are from the origin to the joint center, from the joint center to the insertion, the length of the muscle at that joint angle, and then the angle that the muscle makes with the bone at insertion. So I'm just going to let this play through to make sure that you can see that all, and then I'll pop back in a second. Okay, so you can sort of see that this is a riveting exercise, but what it really sort of shows you is everything that goes into muscle modeling is a lot of detail, and measuring all these points does give us a lot of insight into what muscles are creating certain forces, given a bunch of different actions and across which joints. So you can see that it goes a little bit faster as you get used to it and go through the different joints. I think we made a little bit better time here on the 90 degrees elbow flexion, but just taking the distance that it makes with the insertion point there. And finally, we'll do brachioradialis at 135 degrees elbow flexion. All right, just finishing up taking the angle at insertion there. And we'll take a look at our data. So we have 53 centimeters distance from the joint to the origin, 21.5 centimeters. Oh, sorry, that is 5.3 centimeters or 0.053 meters. 21.5 distance from the joint to insertion, and then our muscle length changes from 21.3 to 23.3 and 23.3 again, with from 45 to 90 to 135. And we go the measured angle that the muscle makes with the bone as 15, 9, and 6 degrees. So very small angles there as you get into the increased muscle lengths. So moving on to our ankle and our gastroc, I'll make this one quick. But we again chose the lateral head, so the posterior surface of the lateral condyle of the femur. So on the lateral femur, just on the back side of the condyle there, and then inserts on the lateral aspect of the posterior aspect of the calcaneus. Sorry. So here we have a quick representation of what that looks like with our fantastic tape job. And oh, I guess I'm gonna have to play the video, right? Yeah. Okay, so you'll see here our skeleton doesn't necessarily love to cooperate, and I have some trouble positioning the ankle in that sort of end range of the joint. I mean, a lot of people who have really tight soleuses or calves wouldn't even get their joint to that angle. Most of the time they can't get too far past 90, but even in the skeleton it was a little difficult with where it would be jamming up. But you can see that Ian is making sure that I just locate it directly at the joint center of the talocalcaneal joint. Yeah. So he's taking the distance from the origin to the joint center. the insertion to the joint center. I'll help him out here and hold it exactly what we did before. Take the entire distance of the muscle. There we go. Ensuring that I keep the joint at the same position. He'll take the length of the muscle. And then finally, using our goniometer, we're going to take the angle that the muscle makes with the bone. Now this one's a little interesting, but the calcaneus sort of has a semi-distinct long portion of it that goes towards the ankle joint there, so that's what I chose, and I just kept it consistent between the two of them. Putting one arm of the goniometer in line with that, and one arm in line with the direction of action of the muscle. Finally, as I disappear and come back here, what we're going to do is position the joint at, I think it is 135 degrees, and we're going to work through these same 3 measurements. Okay, so finally taking the angle that the muscle makes with the bone at insertion. Reading that off, and then as we end that, I'll switch back to our other view here. We'll go through some of the data, looking that from the origin to the joint center was 40 centimeters. From the joint center to the insertion was 6 centimeters, and then our muscle length varied from 45.5 centimeters to 42 as we plantar flex the ankle, changing the degree of interaction with the calcaneus from 53 to 75 degrees from the line of pull of the muscle to the sort of semi-line that calcaneus has going through it towards the joint center. That's pretty much it, guys. Thanks for watching, and I hope this was sort of semi-insightful on how we collect some of the metrics that we can use to calculate force and model muscles in that sort of semi-reductive elastic capacity. Thanks.